Encik Izmir is the founder, CEO, and CTO of Independent X Aerospace Sdn Bhd, a nobleman and famously known with many names such as Iron Man Malaysia, Elon Musk Malaysia, and Mr. Rocketman. From juggling responsibility as a student, segregating time for his education, and his passion in working on his propulsion system, working in a team to manage a well-recognized company like Independent X, Encik Izmir is one of the true guru in leadership. Without any further ado, I would like to call upon Encik Izmir with his speech, the title of The New Space Race.
Hi, a very good afternoon, and thank you for inviting me. My name is Izmir Yamin. So today I will be talking about the new space race. So when I say space race, it directly refers to the space industry and space technological development in terms of which organization or countries can progress the furthest. The space race originally started in the 1950s, right after the Second World War, between the Soviet Union and United States. Back then, the motivation for space race is to achieve the farthest and longest range of ballistic missiles. And eventually, it evolved into launching satellites into low Earth orbit. And then when that kicked off, then the space race officially started in the early 1960s, which eventually put the man on the moon during the Apollo missions. Fast forward today, we are seeing a lot of private companies instead of government agencies worldwide putting man-made spacecraft into orbit around the Earth and doing interplanetary missions. So these days, most of the space missions are encompassing businesses that revolve in helping different various sectors, such as biotech, medical, telecommunication, Earth observation, physical material science, and so on. So a lot of businesses depends on space technology these days. For one example that the common man that is using space technology is like the GPS, which is actually derived from a system called GNSS, stands for Global Navigation Satellite System. And GPS is actually, it's an abbreviation for Global Positioning System, which is owned by the US Air Force. And we have a similar technology coming from other countries like Russia, China, India, and European Union, where Russia has a system called GLONASS, stands for Global Navigation Satellite System. China has Beidou, India has Gagan, and European Union has Galileo. Okay, so the effect and spin-off from this technology is actually helping a lot of sectors and industries today, from navigation to aerial mapping and so on. So this is one of the direct implications of space technology. But these programs are typically launched by governmental agencies. The private initiatives for space industry are things like telecommunications. Like for example, in Malaysia, I think we can experience the use of direct-to-home entertainment system like Astro, and among the unforeseen sectors of the industry that is using space technology is the biotech sector, where they actually rely on the microgravity of being in space to crystallize their protein chains so that they can develop vaccines and create new medicines for curing diseases. So there are a lot of applications these days. using space technology. So therefore, a lot of companies are trying to be in the forefront of using the space technology to make their product better. Like for example, I'm going back to this pharmaceutical industry. Why they need to use space to enhance their product? Because when they develop vaccines, they need to replicate certain protein crystals. Apparently, when they do it in the Earth-based laboratory, the efficiency is quite low. It's roughly about 40% and below. When they do it in space, efficiency goes up to 99%. And the cost of overall development time is much lower when they do it in space, and also yields a higher efficiency compared to here down on Earth. That translates to faster production of vaccines, medicines, antibiotics, and so on. So this is one of many examples. Another example is the area of agriculture, where we are looking into precision farming. Most of the precision farming methods utilizing multispectral mapping, where it can predict the uptake of water and nutrients into the crops by using an infrared type camera. So most of the Earth observation satellite these days are capable of doing such mapping, so that it can actually tell the plantation owners and farmers on how to manage their plantation better to reduce wastage in fertilizer and pesticides, and also increase the yield for the crops. Okay, nevertheless, what I've just mentioned, these are only the downstream side. Okay, in order to get this downstream up and running, where the user can use it to enhance their businesses, we need to understand how the upstream of the space industry works. Okay, so I just would like to give an overview about our company. It's Independence X Aerospace Sdn Bhd. We started in 2013, but our R&D and special interest group working on rocket propulsion had started way back in 2003. Our business model, this nature of business, we are looking into launch services and re-entry services in the future. So the targeted first customer launch will be in 2023. The rocket launcher is capable of carrying 200 kilogram of man-made satellite as the payload and placed in an circular orbit around the Earth. So we are looking into two types of orbit. One is a polar orbit, which is 90 degrees in relative to the planar equator. Another one is in the equatorial orbit. So this is launch services. We'll be providing both dedicated and shared ride launch services. So the rocket will be fully homegrown from the engine development until the airframe. Okay, then next will be the re-entry services, where we are actually providing recovery of satellites that's orbiting the Earth who wants to come back. So typically, before the customers launch, they will launch in our capsule on board the rocket, and then this would normally target the pharmaceutical industries, where they want to bring back their protein crystal samples back down to Earth. So we get their module that will have unmanned experiment cassettes for the protein crystallization process. That will be in our capsule. We'll orbit around the Earth for 2 weeks, because that's how long protein crystal will develop in space. And then after 2 weeks, then it will do the re-entry, which it will generate friction with the upper atmosphere and soft landing with parachute or paraglider. And the sample will be sent back to the clients for further development. Okay. So these are the nature of business, which is the upstream side of the space industry. I think I want to touch upon the strategic space value chain. So the strategic space value chain Typically, they consist of small satellite, both software and hardware, small satellite manufacturing, launch services. So these are pretty much the group cluster that has been taken up by growing space startups and space companies. There are other elements as well in the strategic space value chain, which is space resources, space tourism, space infrastructure, space asset management, aerospace and equities. So with regard to the strategic space value chain, we are looking at different verticals of within the space industry. So we have from the low risk to the high risk. The low risk of the space industry will be covering 4 areas, which is communication, which you can guess, which means satellite communications. For example, you have Inmarsat, Intelsat, LoRa, Eutelsat, Miasat, one of them. Okay, so that's for communication. For transportation, which means all the launch vehicles, includes rockets, spacecraft, launch facilities. This vertical of transportation is exactly what we are in, where we provide launch services as a company. Okay, so the other example of launch providers are companies like SpaceX, United Launch Alliance, Boeing, and so on. And then within the same group of low risk is space infrastructure. So you are looking at companies like Astrotech, United Technologies, Thales, which develops the parts and technology. And then lastly, in the low risk side of things is the global internet, which you all know the Starlink, which is SpaceX has launched to provide worldwide coverage of internet signal, like satellite broadband. So Starlink is one of them, Inmarsat, Intelsat, O3B. So these are all the companies. So when I mention all the name of the companies, between the companies itself, you can say we are having a space race of who gets there first in providing services to the market, to the mass market and private sectors or governments. For example, like SpaceX recently successfully put back man in orbit after many years when the space shuttle retired. So instead of Boeing, so SpaceX did that. So which means they have won that portion of the space race. And speaking of recovery of the rocket after launch, there are companies like Blue Origin, SpaceX, Marsden Space Flight Systems. These companies are racing towards developing the best technology for booster recovery system, which means when the rocket has launched and it jettisoned out the first stage can return back safely nearby the launch site to be reused for the next flight.
Excuse me, Encik Izmir.
Yeah.
Do you happen to have any slides to share?
Yes, I do.
You can click on the Open Share 3 button in the menu.
Sure. Okay, all right.
Seems to be cropped out lah. Okay, better.
Yeah.
All right, okay. Thank you.
So everyone can see? Okay. Yeah, because I went on off the video. And okay, so I'll just skim through from the start, so at least everyone get an idea. Okay, so that's the rocket and re-entry capsule that we're working on. Okay, we are also listed in the new space category. I think this is of the public domain. So there are a lot of other examples of new space companies around the world. So they are developing different technologies, from rocket launchers to satellites to the command and data handling, which can contribute to IoTs and many other downstream applications. Okay. So strategic space value chain, as I mentioned before, we have the space ventures investors. Most of the time, people, when they think of space, they only think government agencies who are funding it. But actually, these days, you got a lot of big private investors that are looking into funding in a lot of space companies. For example, the country of Luxembourg, they are funding a lot of space companies from Asia. Like, for example, Japan, iSpace has been funded, I think, about 90 million euros to the company for conducting robotic space research, and various other companies for things like space mining. So there are a lot of opportunities in the area. I think investment in space happens across the world, from the US, Europe, Asia, Middle East, and Africa. So you can actually see a lot of areas. So if you're interested in space industry, I think you have to be prepared that you are actually entering a new space race, which is defined by a space race competing with different private companies instead of governmental agencies. So that's why it's called new space. New space means it's a private space industry. Unlike just a space race, it's typically traditionally done by governmental agencies like NASA, Roscosmos, JAXA, and so on. Okay, and then there are verticals between the low risk, like I mentioned before, low risk and high risk. So risk off is basically the low risk, risk on, which is the high risk. So I haven't touched upon the high risk. So high risk, you're looking into the verticals like space tourism. If you know the Spaceship One, Bird Uten Virgin Galactic, they will take in ticket. They're charging ticket roughly about $200,000 for anyone who wants to reach the Kármán line, which is 100 kilometers. You don't get to go into orbit, but at least you pass that Kármán line, which is 100 kilometers above sea level, which you are entitled to be called astronaut. So those are part of the space tourism, which is kind of in the risk area. And then we have things like bases and habitats. Bigelow Aerospace, you see here, they actually built inflatable space stations. That is quite revolutionary, because when you can inflate space station, meaning the volume required during launch is at minimum. Then when you go up in orbit, you can inflate the whole module to be an entire space station. So which is quite unique actually. And then you have things like space mining, whereby previously in the early 90s, Japanese Space Exploration Agency, JAXA, has launched a mission called Hayabusa, where they land on an asteroid. They collect some mineral of the asteroid. So this asteroid, typically, they are located between Mars and Jupiter. So that's a huge asteroid belt. And there's tons of different types of mineral, rare earth minerals, noble metal minerals. So there's a lot of opportunities. It's a $3 trillion industry actually, if you can able to harvest and bring it back to Earth, which Hayabusa mission successfully did that. They brought back a small sample and managed to land back on Earth by landing on Australia. So then they managed to bring back the sample to Japan. so which is proven doable. It's just a matter of cost effectiveness. Will it break even the cost of even going there in the first place? Then lastly, will be colonizing multiplanetary bodies like different planets or moons of planets. For example, even on around Jupiter, you have a lot of moons that is potentially habitable. Same with Mars. Mars have 2 moons, even Mars itself. So these are all on the high risk, but they said do it yourself due diligence. So have to evaluate on own self basis. So the complexity goes from bottom all the way to the top. So from Earth, suborbital, low Earth orbit, orbital, so on until you reach Mars. So far, that's most of the probe has gone. There are probes that went beyond Jupiter and so on, like the Voyager and Viking missions. They snapshot photos up to the Uranus and eventually Pluto. Okay, so when it comes to the new space industry, if you're interested, so the new space industry offers all these 8 different verticals, from communication, transportation, space infrastructure, global internet, space tourism, base and habitat resources, and lastly, colonies. So for our company, we are looking into the transportation industry of the space segment. Okay, so this is design that we have finalized and we have submitted to NASA. So NASA have received our design for the rocket launch vehicle that has been published in the NASA report, I think 4 times already since 2015. So we have been requested by NASA last year to be part of their supply chain. So once the rocket launches in 2023, we will be able to launch some of the NASA payloads into low Earth orbit and eventually beyond the Earth's orbit, because we also have plans for Moon and Mars mission. Okay, this launch vehicle, actually, it's not really big compared to the most of the launch vehicle in the market. It is about 16 meters tall, 1.2 meters in diameter, weighs about 12 tons, and it will have 2 stages. The first stage will consist of 9 locally made and built rocket engines, which is capable of firing up around 30 kilonewtons of thrust. And then the second stage will consist of only 1 engine that would put the payload into orbit. Okay, so we are looking into launching mostly CubeSats, cube satellites, if you're not familiar. Cube satellite is the kind of satellite that is very small. So 1U is being designated as 10 by 10 by 10 centimeters in terms of cube size. So that's 1U. So most of the companies, universities, organizations, they like to build this kind of satellites because it's quite handy and easy to construct, since this size is much smaller and components are much cheaper than the bigger satellites. And also it's quite cheaper to launch as well, since it's very lightweight. Maybe you're wondering what's the launch price, typical launch price. Typical launch price, it will cost you about, but you have to launch in a huge amount of mass. So it will cost you about roughly $3,500 per kilogram. That's for a one-off 1 ton to 1.5 ton. If you're just going to launch a 1U CubeSat, excuse me, it will cost you roughly about $200,000. So if it's just launch a small CubeSat, so it will be very expensive if the volume is and the mass is quite small. Okay, a little bit about my background. So this is my biocycle. I actually studied degree in mechanical engineering. Prior to that, I studied diploma in aerospace engineering from UITM. Then I did my business administration in Illinois Institute of Technology in Chicago, USA. I also studied aerospace engineering in Masters of Engineering in University of Malaya. I used to work in Strand Aerospace under the Airbus aircraft program, which I was a project engineer and also structural engineer for the Airbus A380, A320, and A400M. But before I started working, I built a lot of self-made projects that some of them are class-based projects, some of them are not, but mostly are not. So I spend my free time building jet engines and rockets. So I've managed to build my first jet engine, which is only costing me back then about 80 ringgit. So it managed to fly at the speed of 200 kilometers per hour. And this engine is quite unique. It's a jet engine. It only has one moving part, which is doable with just few materials. So then next I design and develop the rocket propellant, which is the rocket fuel and oxidizer, machine my nozzle, build the fuselage, and eventually launch a 1 kilometer altitude rocket vertically and also horizontally. And then eventually I upgraded the solid propellant rocket, which is the second variant, which is the size of the rocket is twice the first rocket. The second version is 2.2 meters tall. And then the third version of the rocket, this is a bit unique. It's based on liquid propellant instead of the early two of those models which are solid. So liquid propellant is never been done before in Southeast Asia. So that was the first one. And also the unique thing about the liquid propellant rocket is actually electrically pump rocket fuel into the rocket engine, which was one of its kind in the entire world back then. When I did this was in 2005. I managed to win the gold medal in Europe in 2006. And just bear in mind, I was still studying back then. So I stopped at that because the resources required to go to the next stage is quite huge. So I decided to continue rocket when later on I graduate and start getting collecting my own resources, which is building the company to rebuild back. And moving on, I built a low subsonic wind tunnel, high-speed aircraft. Back then when drone was not popular. So I built quite a number of aircraft from scratch, design and built. And then airships, hydrogen technology, hydrogen cars. So these hydrogen cars that you see here are designed and built purely without outsourcing, from the body structure down to the chassis, down to the drivetrain and power plant from scratch. And then the hydrogen fuel cell UAV, which is a 5-meter long wingspan from tip to tip. That's quite huge, but it only weighs about 18 kilograms, 1/8, and it's powered by hydrogen. And so that's a little bit about the background. Okay, so these are glimpses of pictures of tests and the development of the projects. Oh, by the way, our team of the Shell Marathon car, which is a hydrogen category, has won several competition in the Shell Marathon. I think we became champion for 4 years consecutively. And it's an Asian level series, so entire Asia. Okay. So that was our first meeting for the Google Lunar X Prize, which I didn't mention yet. So Google Lunar X Prize is a competition organized by Google, the search engine company, back in 2007. So 2007, we applied for entering the competition, and we got the result of participation in 2008. So out of 8,000 applicants worldwide, 32 got accepted, so we were one of them. And then that was our first meeting while I was still a student. I think we were the youngest participant team in that entire summit at that time. So in the picture there, you see that's Peter Diamandis. I think he's quite famous these days. He runs the XPRIZE Foundation. If you can go to xprize.org, you see a ton of multi-million dollar prize competitions that I think you can join yourself. But in our case, we joined the Google Lunar XPRIZE, where the prize money was sponsored by Google themselves. So it was a 30 million US dollar prize money. However, the competition had ended last 3 years with no winners, of course, because to go to the moon at the cheapest cost is quite difficult. So no winner. However, after the competition, there was 2 participants attempted to get to the moon. Israel was one of them. They managed to arrive at the moon's orbit, but eventually crashed their craft. You can check it out on the public domain on the internet. The name of the craft is Bereshit, and the team name is Space IL. Okay. So rocket development, ID stands for independence. So we started very, very small. So this is our test rig we designed and built from scratch. A lot of innovations that happened. I did this when I was studying as well. So including the rocket propellants, the motor, the nozzle. If you can see here, the thrust measurement system developed using off-the-shelf materials like ruler, speaker volume control as the carbon scrub, then connected the wires to a PC data acquisition, and the PC will pick up the data and plot in Excel. So we did a lot of innovation, all home built. And this is the static test firing of the Independence 2. There's Independence 3, this is liquid propellant. This is actually, just to inform you, it's a world's first electric rocket. So actually what had happened, I did not continue from this point. That this was 2006. I did not continue because if I would to continue from that point, it will take in a lot of resources. So I decided to do aircraft instead. And I told myself I will resume this project when I graduate and start working and opening up my own company. So that's what we're doing right now. Okay, so these are a bunch of medals that we have won in relation to the rocketry system. Okay, back to this DNLV. DNLV stands for Dedicated Nano Launch Vehicle. It is actually listed and published in 3 organizations: NASA, Northrop Grumman, Orbital ATK. We also have a US patent, Malaysian patent, and global PCT. Okay, so this is the NASA report back in 2015. So they have published 4 times already to date. So this is the listing in Orbital ATK, Northrop Grumman. This is our feature of the product in a French aerospace magazine, which actually what it mentions there, we managed to get a collaboration with the French Space Agency to provide re-entry services. So this is all written in French. So we're the only startup that was featured in the French Aerospace magazine in 2018. And it's quite an honor for Malaysia to be highlighted in Europe for this particular project. A year after that, we were doing the Samsung high altitude testing for the S10 phone launching using the similar capsule vehicle. So this is a German magazine that we were featured. Among all the featurings were actually highlighting our hydrogen technology used in the rocket and capsule system, because we focus mainly on hydrogen fuel cell, where hydrogen fuel cell has a better energy density than batteries, So that's why we've been picked up a lot in most of the European media. And this is, I think, something to be proud of as Malaysian. We have brought Malaysia to the world map by putting Malaysia's name there in the National Geographic magazine. If you want to backtrack, you can ask Kinokuniya for an order. It's August 2017. And you can see Malaysia Independence Act is highlighted in this National Geographic magazine. This is for the Google Lunar X Prize competition. This is our US patent for the liquid rocket engine that is using hydrogen fuel cell as part of the power subsystem. An award by Google and X Prize Foundation as the Pioneer Award. In 2014, I was nominated alongside Elon Musk in the World Technology Award in New York City, organized by Fortune and Time magazine. So it was quite an honor to be beside Elon Musk. Back then, he was already famous, but not as famous as today. This is one of our earliest customer when I quit my job in Airbus, and I started to be dealing with companies like Safran for development of Hall effect electric propulsion. So they wanted to miniaturize the Hall effect electric propulsion and to be manufactured here in Malaysia. However, that time the semiconductor industry just experienced a downturn for a bit. So we decided to KIV the project, but I was stationed there in Europe for several months working on propulsion related projects. So we also been featured in the City de l'Espace website for being called upon by the French Space Agency to give a presentation on our technology and product in France, Toulouse. Okay, during the Google Lunar X Prize, at the last mile, we decided to team up with an American team called the Synergy Moon. Okay, so one of the benefit of doing that competition is the global outreach. So this is one of the example done by some of the participants. So we have this lunar rover and Mars rover. Okay, so this is our rover done by Independence X Aerospace, meant for moon mission. This is our spacecraft, meant for the landing. Okay, so besides doing the space company, I also run a drone company called Pulsar UAV Sdn Bhd. In 2017, we have given the award of Frost & Sullivan Malaysia Excellence Award for Malaysia Entrepreneurial Company of the Year for Unmanned Aerial Vehicle as a manufacturer and technology provider. So we have customers like both tea plantation, the oil palm industry, oil and gas, and telco. So we built drone from scratch. So we get most of the proceedings and profit that we would reinvest back in the rocket program. Our main technology of this system is the hydrogen fuel cell. So if you are interested more about hydrogen fuel cell, to be involved, to get to do projects on it, you can get in touch with me. So would love to talk. So this is actually our previous hydrogen fuel cell drone that I mentioned before. It's a 5-meter long wingspan. I think Asia's first hydrogen fuel cell powered UAV. This is actually my final year project when I was in university. I designed and built the whole UAV from scratch. It's a 5 meters long, 18 kilograms. And this one was my preliminary research on onboard hydrogen generation. Okay, so I've reached to the end of the slide. I will be happy to answer any questions. So to recap, our business model is commercial nano satellite launching services and re-entry capsule services. So as I mentioned before, the new space race is actually it's a new term for privately run space industry that are competing among private companies like SpaceX against Blue Origin, against Boeing, to be the most cost-effective way of getting into space. So if you're interested to know the original space race, which is between the Soviet and the US, there's a lot of interesting facts and stories about it. If you want to ask any questions, feel free to ask. I think I will end my presentation here. Thank you very much.
Okay, thank you, Encik Izmir. Now we have a few questions from the participants. Okay, number one from you, Vinesh. Sir, where is your rocket launch site located in Malaysia?
Okay, we have various launch sites, but based on the approval, at the moment, the government is evaluating. So I myself don't have the information right now, but we are planning to launch due east. So anywhere in the east coast of West Malaysia.
Okay, from Shauki Azim, sir, I as a civil engineering student, where do you think I can further with my study in the aerospace field?
Actually, that's a good question. In Boeing, they have close to 70% civil engineers. So because they treat civil engineering as one of the very important areas, like for example, when you build an aircraft, you actually treat it like a flying building. So it's very, very significant, how they call, traits to be in the aerospace industry. So don't worry, as long as you become structural engineer for both space and aviation, I think there's always job opportunity over there.
From Muhammad Daniel, from your opinion, will Malaysia expand the field of aerospace in the future? If government will fund and support this field?
I think if government want to support this field, it must first prove that this field can be of use to the public. Like for example, improve the efficiency of the daily operation, like in agriculture, in remote sensing, in communication. If you can prove likewise in that direction, yes, I do think government will be able to support. But if it's a one-off program like what had happened in the past, I think it will be much difficult for government to put its commitment. So my take for that is try looking into solving problems into areas that could use space technology to solve the problem. If you can come up with a solution, try to prototype and increase the TRL from ideation up to TRL 6 or 7. TRL stands for Technology Readiness Level, which you can look it up on the internet. It's a standard for tech readiness level developed by NASA to tell if your technology has matured or not.
From Aiman Hazim, what do you think the prospect of green renewable energy engineering in Malaysia?
Okay, renewable energy has a lot of high prospect. In fact, we have an entire kementerian named after renewable energy, which is Kementerian Teknologi Hijau. I haven't checked if it's been consolidated with the previous government under MESTEC, but there's a lot of effort. In fact, renewable energy, even they provide opportunity for common man to go and get license and to sell back power back to the grid. So I think it's under SEDA program, SEDA, you can look it up. So they have various renewable energy system like solar and wind. If you can generate excess power, you can sell it back to the grid and you can get paid for it actually. So in fact, the business is quite huge actually. There's a lot of solar plants around in Malaysia.
Okay, sir. Just now you mentioned about how civil engineering have 70% opportunity to venture into the aerospace field. But how about electrical and mechanical engineering students? Do they have equal opportunity in this field?
Actually, they, without saying, definitely have a lot of opportunities because a lot of flight subsystems, for example, in the electrical electronics, heavily uses this kind of subsystems like flight controller, command data handling, electrical power systems, and so on, and communications. So definitely these are fields that will be open. When you want to make a satellite, in fact, the entire satellite is in fact requiring expertise from the electrical electronic field. Of course, satellite also needs things like structural bus, where you put in all your electronics on a system bus, which will require mechanical expertise to withstand the vibration of the launch, withstand tumbling in space, withstand the harmful radiation. So you need to have certain protection like tantalum coating or graphene for a modern material as to protect from harmful space radiation and so on. So that goes without saying, electrical, electronics, and mechanical and chemical actually have a good opportunity in space sector.
Okay, another question from Yuvenish. Sir, for the re-entry capsule, how do you know where will it land and how do you control the maneuver so that it will not crash on building or city?
Okay, so this re-entry capsule, during a re-entry approach, it will have several phases. So the first phase, you need to have an aero braking in the upper atmosphere. So as the capsule is being suspended in orbit, it is actually traveling at about 7.9 kilometers per second. So if you want to enter the Earth's atmosphere, you need to reduce that speed. So you only reduce that speed above a certain location or a certain country that you want to start descending, assuming you have already account for that trajectory, so you don't want to overshoot or undershoot. You want to exactly brake, slow down your speed for the re-entry. Now, once you enter the upper atmosphere, you will actually go through a certain phase, and your Mach number at that time will be about Mach 27. Plasma will build up on the heat shield during re-entry. And eventually when you reach about 30 kilometers, parachute will start deploying. In the case of parachute, you will only have a guesstimate within a certain radius that it will drop down. So typically, if we're using parachute, we will drop in the ocean. If we are using paraglider, then we'll drop in a designated landing pad. So paraglider is more control. Parachute is more of a slow down the descent rate.
From Muhammad Amza, hello sir, can you give some advice on how to start an aerospace startup? Where can we start to step forward to be a successful startup?
I think you can start by looking into what problems do you want to solve and what company you want to be in general. For example, if you see Kodak, okay, I give a different industry as example as to give you the idea. What do I mean? So you look at Kodak. Is Kodak a film company or an imaging company? So since the beginning of time, they have called themselves an imaging company rather than film company. So when the age has turned to digital cameras, most of the filmmakers, the film roll using argentine bromide cannot survive the market because most of them are switching gears to digital cameras. But Kodak still remain relevant because they are calling themselves as imaging company. So it doesn't matter it's a film-based imaging or digital-based imaging. So when you go into business, make sure you encompass the bigger picture rather than the smaller picture. For example, when we open up the space company, we are looking into providing that linkage between space and Earth. So it's a transportation services, but there's a bigger objective than transportation. So we're looking into big data. So if we can have satellites orbiting Earth, taking photographs every minute around the Earth, capturing agriculture image, capturing data terrain model image, and also if we can transmit back telecommunication signal back down to Earth and receive back from the Earth. So you have tons of data flow by just using satellites. So that's why a lot of countries that launch satellite into space, most of their big commodity is that data. So that's why we look at Independence X Aerospace, not just a transportation company, but a big data company. So you have to ask yourself what problem you're trying to solve. So in our case, where we have the data, our main objective is actually to solve agriculture wastage and low yield. We want to improve those things. And secondly, we want to improve the livelihood of humanity by transmitting free internet access from space by giving free online classes to all these remote areas around the world. So we start off with the equator first. So, identify the problem, get the problem statement and find the solution and start to prototype that solution. So you can start small. So that's why, the basic tools you need, you should get available to you.
Thank you, Encik Izmir, for the terrific sharing session. That's the end for today's session. I would like to take this opportunity to thank Encik Izmir and Miss Ifafrina for being here with us today. Not to forget to all committees that has worked hard, been working hard to make today's happen. Thank you, UNITEN, for having this program for us, and thank you, YTN, for supporting us. To all participants, thank you for your support and your active participation into this session. May today's session benefit each and every one of you, and we would like to wish you all the best for your future endeavor. Lastly, remember, the change of the world starts with you. With that, thank you and Assalamualaikum.
Thank you so much.
Thank you, Cik.
Thank you, sir.
Yeah, thank you everyone. Thank you.